Hi folks, this video is going to show you how to complete the work for this week in the file called Graphs of Motion. So the page that you can see in front of you just now, you're going to copy this page into your jotter. So at the moment, because we're in third year, we can call these speed time graphs, but you could also call them velocity time graphs. And basically what it shows is it shows the motion for an object over a certain period of time. It could be for part of a journey or it could be for a whole journey. And the line tells us information about the motion of the object. Now the three shapes of graph that tell us about the motion are across the top of this page here. So if the line on a graph is horizontal and goes straight across, doesn't go up or down, that tells us that for this part of the journey, the object is travelling at a constant speed. It is not getting faster or slower, so therefore the acceleration is 0 at this point, because the object doesn't increase or decrease its speed, it remains constant. So anytime you see a horizontal line on a graph, it means the speed is not changing. If you see the line on the graph sloping up the way, that tells us that the object is increasing its speed and would therefore be accelerating. And you would say that that's positive acceleration because the object's speed is increasing. So anywhere that you see a diagonal line going upwards, that means that your object is increasing its speed, it's accelerating, and it's positive acceleration because there's that increase of speed. If you see a line which is doing the opposite and it's sloping down the way, it means we're getting the opposite. We're getting decreasing speed, which we would call negative acceleration, because the speed of the object is going down this time. So anywhere on a graph where you see a line sloping down the way, it means the speed is decreasing, so the object is decelerating, or it has negative acceleration. The final thing that's written here is about how steep the line is. The steepness, in maths you might have heard the word gradient, which basically means steepness. That gives us an indication for the acceleration of the object. So if the line is steeper, or if the line has a larger gradient, that means it has a greater acceleration. To give you an example, if I draw a line beside this middle one here that looks like that, the blue line is much steeper than the one I've highlighted, which is here. The blue line is much steeper than the green line. That means the blue line shows a higher acceleration value because the object is increasing its speed over a shorter period of time than the one in green. So the steepness can not only tell you if something's accelerating or decelerating, but it can also give you an indication to the value of this acceleration or deceleration. The steeper the line, the greater the acceleration. If the line is less steep, there's much less acceleration. So that's another thing that we can look out for. After you copy this part of this page, you're going to copy and complete this section down here. So this first graph, if you draw it into your jotters, and I'll just highlight the lines so that we know what one we're talking about. So we've got this steep line going up here between 0 and 10 seconds. It then is a straight horizontal line between 10 and 15 seconds. And then it slopes downwards between 15 seconds and 20 seconds. So what we're going to do here is we're going to copy and complete the paragraph that is going to describe the motion that this graph shows us. So for 0 to 10 seconds, from the beginning till we reach 10 seconds, there is increasing speed. Because the line is going diagonally upwards. That means we're increasing our speed. That means we're accelerating. We start off at 0 meters per second and we reach a final speed of 10 meters per second. And I'm just getting those numbers by reading them from the left-hand side of the graph. Like I said, you might see velocity, but that just basically means speed. So using speed or velocity is fine. So we're increasing speed from 0 to 10 meters per second, which means we are constantly accelerating. So constant or uniform acceleration goes in there. If you want at the side, you can write plus A because it's positive acceleration. If we then look between 10 and 15 seconds, that's when we've got the horizontal line. So from 10 to 15 seconds, we have a constant speed. Try and fit that in there. Constant speed. And the value of that constant speed is 10 meters per second. If you want, you can add to that middle line by saying A equals 0. There's no acceleration because the speed is not going up or down, it's staying constant. And then from 15 seconds to 20 seconds, we've got a diagonal line down the way. So that tells us that the object is decreasing speed. And we're starting at 10, which is this point up here, is 10 meters per second, back down to 0. So from 10 to 0, which means constant or uniform deceleration. And if you want, you can call that negative A, because we're decreasing our speed. So that's what we need to be able to do. Looking at a graph, look for the three shapes, and then between each time period, be able to describe the motion. And at the moment, your three choices are the ones that we've talked about at the top. Constant speed, increase in speed, which is positive acceleration, or decrease in speed, which is negative acceleration. Okay, let's look at the next one. So here, you'll notice that we're not starting from 0 this time. We're starting up at 25 meters per second when the graph begins. And we've got this diagonally sloping line upwards. So from 0 to 10 seconds, you can see that we're increasing speed. And we're starting this time, we're not starting from 0, we're starting from 25. And we finish up here. We're at 40 meters per second. And that's constant acceleration. We then look at the next section, where we've got from 10 seconds to 14 seconds. We've got a horizontal line, which means that 40 meters per second that we've reached doesn't change. So between 10 and 14 seconds, we've got constant speed. and the value is 40 meters per second. In the last section, we are between 14 and 18 seconds. We're going downwards diagonally. So that means our speed is decreasing. We're decreasing our speed from 40 back down to 0. And we would say that that's constant or uniform deceleration. And the constant uniform part just means that the steepness of this line, I'll highlight it in a different colour this time so you know what one I'm talking about. The steepness of this line isn't changing between 14 and 18. And that's what the constant or uniform part means. Okay. And again, that's got the three shapes of graph that we should be able to identify. On the second sheet, you can download your own copy of this document and you can sketch the shapes of graph on each set of axes. If you're not, if you are doing this on paper, that's absolutely fine. You're just going to sketch the graphs on this page, which means that you don't need any of the grid boxes and you don't need the scales necessarily to go up by 1 each time. Because we're sketching graphs, all we need to have are the labels and units, the shape of the graph for each part of the journey, and the key numbers. So I'll show you how to do that on the whiteboard part. So for this first graph here, we want to sketch the graphs that are going to show this motion here. So from 0 to 5 seconds, we want the speed to increase from rest to 10 meters per second. Now it says to the right, and for you all that means is that the graph is going to go from left to right, and all the lines are going to be above the 0 along the x-axis. So from 0 to 5, we want to increase velocity from 0 to 10 meters per second. So what I would do, if I'm doing this on paper, is draw my axes for my graph. Make sure we can use a ruler or a straight edge. I'm then going to mark V for speed or velocity in meters per second on the left. I'm going to put time in seconds along the bottom. And I'm going to put 0 in the corner there. Now if I'm sketching the graph, like I said, I'm not bothered about not having grid lines on my page, and I don't need to have a scale that goes up by 1 for speed and for time on each axis, because I'm just sketching a graph. So we want from 0 to 5 seconds, we're going from 0 to 10 meters per second. So to show that, I would start from 0 in the corner. I would then go along a little bit and mark in a 5 at the bottom, because it's 5 seconds that I'm focusing on, between 0 and 5 seconds. Then up the side, I would go from 0 and I would mark in 10 metres per second. And because I'm increasing my speed, my line has to be diagonally upwards. So I would just line up the point where 5 and 10 meet each other. And then I can take my ruler or straight edge and have a line added like that. So that shows that between 0 and 5 seconds, I'm going from 0 metres per second to 10 metres per second. What I can also do, because I'm just sketching, is I can add a wee dotted line going across to show that at 5 seconds I've reached 10 metres per second. So the first stage for this graph is added. Second bit of the graph, from 5 to 15 seconds, I want a constant velocity of 10 metres per second between 5 and 15. So if I go back to my sketch, the next number that I need to add to the time part is going to be 15. And this time I'm not going to be sloping up or down, because from 5 to 15 seconds it is just 10 metres per second. So all I do is mark in when I've reached, make a wee mark when I reach 15 seconds, take my straight edge or my ruler and have a horizontal line to there. And that's me showing constant velocity between 5 and 15 seconds, and it's a velocity of 10 or a speed of 10 metres per second. So the second part of that graph's done. Last part is between 15 and 20. This time I'm decreasing from 10 to 0, or to rest. So the next time that I mark down on the time axis is, double check, 20 seconds. So mark 20 down there. And 15 to 20 seconds, I'm going from 10 metres per second to 0 metres per second. So this time, I'm going to line up my ruler or straight edge with the 20 seconds at the bottom, like that, and draw the line down to there. So because I'm sketching the graph, it's okay that I've got numbers missing, if you like. So there's no numbers between 5 and 15, there's no numbers between 15 and 20, but that's fine because I'm just sketching the graph. Okay? If you're doing the work digitally and you're using a copy of this page, then the numbers and the axis are already there for you, so all you're doing is just adding the line, so that's absolutely fine as well. Whatever way suits, it's obviously going to depend on which device you have access to. So we're just sketching the graphs for each of the 4 examples on this page. Okay, here's the page again for the first example. I can post a picture of that onto Teams as well if anybody wants it. But that's what sketching a graph looks like. Make sure you've got your labels and units for speed and for time. And at each point, make sure you've got the key numbers. Now earlier, I added a dotted line across from the 10 so that we knew that 5 seconds means 10 metres per second's been reached. If you want to draw a dotted line down to the 5 so that those points match up, that's fine. If you want to draw a dotted line there as well to show that that's where 15 seconds is, that's fine as well. So you're going to sketch the graphs for each of the next 3 examples on this page. On the third page of this file, you're going to look at each of the 4 graphs and you're going to describe the motion. So you can use the first page of this file again to remind yourself what the 3 shapes of graph mean. So what does it mean when the line goes across? What does it mean when it goes diagonally up and diagonally down? You can use the first page to remind you of that. And the final page in here is to look at the tables of information and sketch a graph to show the speed at each time of the journey. So you're going to do the same as what I've demonstrated for the earlier example. Any questions? Anything you want explained again? Please feel free to rewatch the video or post any questions that you have onto the Teams page. And we'll speak to you all soon.